Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today, in our 420th episode, we have an interview with Brigid Christensen and Mike Thompson, all about PalaeoPoems.
Oh yeah, really cool project.
Yeah, the not just poems about paleontology, they're basically poems from people that know a lot about paleontology, sort of talking about their own work or work that they're very familiar with. So it's really cool. And they go back a very long time, surprisingly long.
Yes.
And we have Dinosaur of the Day, Eucamerotus.
Yes, and the last of our SVP news, including an item about Big Al, which we prematurely talked about.
Oh, yeah. Yeah. You may have noticed last week that the title of last week's episode briefly had Big Al pathologies in it before we quickly removed it and replaced it with something else.
Yes, we didn't mean to talk about Big Al in the last episode, but instead we'll be doing it this episode.
Yep. And I have a update on Spinosaurus and what people think about it swimming.
Ooh.
And of course, a fun fact. But before we get into all of that, we want to thank some of our patrons for helping to keep the podcast running. We have 3 new patrons to thank this week. There's Zoe Saurus, Gabrielle, and Stevoceratops. And Stevoceratops is new to the shout-out tier, so thank you very much for upping the pledge, and thank all of our new patrons for joining and helping to keep our podcast running. And then rounding out our shout-outs, we've got James, Leo, Ray, the Tolbert family, Gabe, Kelly, and Greg.
Thank you so much for being our patrons and supporting our show.
Yeah, we're coming up to the holidays, so we always think about what we're thankful for, and we are always very thankful for our patrons. So jumping into the news, gotta start with the Spinosaurus swimming, because that's always what people want to hear about.
It was certainly big news on social media.
It's always big news whenever there's anything about Spinosaurus. So this one was published in eLife, which is open access and full of nice pictures, which means that anybody can go see them. It's a very long article. I was planning on doing more than just this article, but this one was so in depth that it took up a lot of time. But I think it's worth it. So it was published by Paul Serino, a very famous paleontologist, and lots of co-authors on it as well. The title of it basically tells you where the authors stand. The title is Spinosaurus is not an aquatic dinosaur.
That's been a big debate since, I think, 2014.
Yeah, I think that was basically when it kicked off. And that was when the big paper was published by Ibrahim, basically saying it was aquatic. So specifically, what they're trying to determine is if Spinosaurus was a, quote, low quadruped on land, but a capable pursuit predator in coastal waters powered by an expanded tail, end quote.
Yeah, you can't discount that tail. There's been papers, at least one big paper on the tail.
Yeah, it was a really big discovery because obviously that tail has a fin-like sail along its top and to a lesser extent on the bottom. And since we now know that, it seems like it needs to be included in its aquatic abilities. Although I would say they threw some pretty major shade at the 2020 Ibrahim paper that described the tail because they said, quote, the propulsive capacity of the tail in water was judged to be better than terrestrial counterparts by oscillating miniature plastic tail cutouts in water, end quote. Which makes it sound like it was just a trivial thing, like well, they had some
plastic
little plastic
cutouts.
Things and wiggled them back and forth and then determined what it was. I don't think it was really all that bad. I think when you look at the tail, you do see that it had this higher profile, which presumably, if it could move it back and forth, would help with propulsion. I think it's pretty reasonable. But to test the hypothesis, they used CT scans of the skeleton to determine the bone density, and then they added missing bones as well as hypothetical flesh to the model. And really the crux of this paper is that fleshed out, pun intended, model, because it's really a question of how do you recreate Spinosaurus?
Isn't that always the question for every dinosaur? Because we don't have that many dinosaurs where we know every single detail.
Yes, but I think in this case, some of the subtle differences really impact whether it was quadrupedal or bipedal, and therefore whether you might expect it to be a lot on land or in the water, because as a carnivore, if it was quadrupedal, it's not going to be able to do all that much outside of the water, presumably. That's been one of the hypotheses thrown out there in the past. And it could show you about how quickly it could move. So if it was just sort of stuck in the water, it also can tell you things like how flexible its tail was, how buoyant it was. All of these types of details really need a detailed model of the dinosaur. And so the differences between the models make a really big difference. So in their model, they had to include everything because they were looking at stuff like buoyancy. So in addition to that skeleton being fully reconstructed, they had to include air sacs, lungs, muscle, and a really precise map of how much flesh it had around its bones.
Mm-hmm.
But even without any of that flesh, the skeleton itself is quite different than Ibrahim's construction. There were a lot of differences, and basically all of them equate to the center of mass being closer to the hips, farther back. Because in Ibrahim's, it was pretty far forward, and that was used as evidence to say, well, it looks like it was probably leaning on its knuckles or being semi-quadrupedal, or maybe even an obligate quadruped. So if you think of a Spinosaurus like a teeter-totter with the legs in the middle, because if it's bipedal, its legs have to be near the center of mass, because otherwise it's going to teeter too far forward or too far back. And in that Ibrahim model, the center of mass was pretty far forward, and therefore they thought it was quadrupedal. So these researchers found that Spinosaurus had a shorter back relative to the Ibrahim model, which shifts the center of mass towards the hips, because then the tail is the other end of the teeter-totter. So if the back gets shorter and the tail's the same length, it brings the center of mass back. It also had a shallower rib cage, which also reduces the mass in front of the hips because it's just like a smaller torso. It had significantly shorter forelimbs in their model, I think like 30% shorter.
Oh, wow.
Which would have made the front lighter because the arms are smaller, but it also would have made it harder to reach the ground as a quadruped. And then it also looks like in their model, the tail was recreated as a little bit longer, although they didn't really call that out in the description. So that's another, all four of those factors basically bring the center of mass farther back and away from it being quadrupedal and more like being bipedal.
But it sounds like they still thought it was quadrupedal.
No, they think it was bipedal.
Oh, but a low quadruped on land?
So that's the hypothesis that they're testing. And usually when you test a hypothesis, you try to disprove the thing. So that's what they were trying to do.
Okay, I got it.
In the end, what they had was that the center of mass was about 15 to 29 centimeters in front of the hip socket. So it's basically up to about a foot in front of the hip socket. That range from 15 to 29 is because there are different amounts of air sacs in their different models. So on the low end, the 15 centimeters, that's if you have a bird level of air sac. So a lot of air in the abdomen. And obviously, if there's more air in front of the hips, it's lighter. And so it teeters back farther. There's less weight in front of the hips. But on the other end of the scale, you've got the lizard airspace model. But even with that, that's the heaviest front. It's only 29 centimeters in front of the hip. And that's much closer than the latest Ibrahim paper that put it at about 100 centimeters or a full meter in front of the hips. And even at 29 centimeters forward, the center of mass would have been above the toes, which is presumably okay for a bipedal animal.
Tottering over to the toes.
Yeah. It doesn't seem ideal to have to have most of the weight on the toes, but it's better than, it being in front of the toes entirely. Another interesting detail is that in total, their model is 1 meter shorter than the previous model at 14 meters or about 46 feet long. Interestingly, they also recreated the sail as nearly a semicircle. It's not too unlike the Jurassic Park 3 model.
Oh, we're going back.
Yeah, it seems like it. It's much less squared off, and it doesn't have any dip in the middle like you see on most reconstructions of Spinosaurus these days. They also found that the tail was too rigid to work as a flexible fluke, but instead acted more like a, quote, pliant billboard, end quote, which actually makes that wiggling piece of plastic sound pretty good.
Yeah.
Because, that's basically what a pliant billboard would be like, a plastic thing, but semi-rigid in the water. They repeated the point that no vertebrate swimmers have a large, rigid back sail.
Well, that back sail is a little perplexing.
It is, because basically everything that swims in the water has as streamlined of a body as possible. It's always possible that Spinosaurus was sort of an early animal getting back into the water. So it just hadn't gotten through all these evolutionary adaptations yet. But still, that sail is crazy huge. And the closest relatives we know of don't have that. So it would be weird if it was the more aquatic one, but had this very not great for swimming adaptation on its back. And they point out, too, that a lot of times people talk about sailfish because it looks sort of like a sailfish, but sailfish can fold their sail down while swimming, something we've talked about before. And Spinosaurus definitely couldn't, because this is literally its vertebrae sticking up. It's not a separate structure.
Yeah.
So getting on to their results, they found that Spinosaurus couldn't dive. Their reconstruction of its skeleton made it too buoyant to successfully dive.
And this isn't the first paper that's found or that's come to this conclusion.
Yeah, it reminded me a lot of an earlier paper that showed Spinosaurus being too top-heavy to swim because it had too high of a center of mass from its sail. And I checked, and that paper was by Donald Henderson, who's also the third author on this paper.
I did recognize his name on the paper. Like, yes, that's one of the Spinosaur experts.
Yes, I don't think it's a coincidence that there's a big analysis on how top-heavy it was in this paper. We talked about that paper way back in episode 195 if you're interested, but the gist was that Spinosaurus was too buoyant and top-heavy, so it would have had a hard time staying upright. Basically, it didn't have the right arms and leg pushing ability to sort of like push from the side, and with it being all top-heavy, it would have just flopped over on its side all the time, was the proposal.
That's not what you want in the water.
No. Also in that paper, they showed that Spinosaurus couldn't sink in their model until its lungs and air sacs were 75% deflated, which sounds crazy, like a very exhaled lung to be underwater with. But for comparison, alligators in their model sank at about 40 to 50% exhaled, so it's not that crazy. And at that amount of exhaling, alligators can pursue fish because, as a random aside, according to Texas Parks and Wildlife, alligators sometimes bite onto fish lures, which sounds horrifying if you were fishing and an alligator like got up out of the water.
That is an unpleasant surprise.
Yes. Although according to the Texas Parks and Wildlife, quote, this activity does not constitute a threat to humans, end quote.
Okay.
Which it really seems like it does.
Maybe their alligators are far enough away. That's why they're not a threat.
If you're fishing, the lure is usually not that far away.
Yeah, well.
If you're luring alligators to you, that seems like it would be a threat. Although I suppose if the alligator is in a I'm looking for fish mode, then maybe it's not going to come for a human. And I think they were mostly talking about people fishing from boats. It's probably harder for an alligator to get out of the water into a boat, but I don't know. It seems terrifying. I never want to fish anywhere where there's alligators now. So as a result of their model swimming, Spinosaurus, quote, was bipedal and in deep water was an unstable, slow surface swimmer, end quote.
Oh, very much the opposite.
Yes. Yeah, exactly. The exact opposite of a pursuit predator that could swim underwater. This shows them being on top of the water and unstable even while on the top of the water. That doesn't mean, though, that Spinosaurus wasn't semi-aquatic.
There we go back to what's the definition of semi-aquatic.
Yeah. So it still would have been semi-aquatic, but it would have been more like a heron than a hippo, basically just standing in the water most of the time is what they propose. And I think they even said, well, it might have had denser leg and foot bones because that might be helpful when you're in water, standing in water, to reduce the buoyancy of the legs that are in the water, because the buoyancy is only affected by the parts of the body that are in the water. So it doesn't matter if you have big air sacs in your head and neck and body if those are above the water. And it doesn't matter if you have a huge sail if it's above the water. But if your legs are really dense and your toes are really dense, which they are from the CT scan data, maybe that's the part that's in the water because they're just standing there.
Then what was that sail for?
Display. That would be the answer for most things. It makes it look bigger. It's already like the biggest thing. So if you're trying to show off and be imposing and being big. And I find it kind of interesting too, because if they're hunting things in the water, it's less likely to scare off prey if the big display structure isn't really visible to the animals they're hunting.
Or if the prey somehow comes out of the water, maybe it scares them more.
Yeah, which you don't really want to scare the prey. But Yeah.
Scare them out of the water.
Oh, I see. Like startle them straight up in the air like a cartoon.
Yeah. Then they're flopping on land, easier to get.
Yeah. Apparently, I just learned today that antelopes jump straight up in the air. It's got a whole bunch of different names like pronging or springing and things like that.
Oh.
Yeah.
Like goats.
Yeah. Yeah, that's one of the animals that does it. They don't know why they do it either. There's a bunch of hypotheses, but anyway, that's too much of a digression. So back to Spinosaurus. They estimate that it swam at under 1 meter per second, or about 2 miles an hour, and that's about the speed of an average human swimming.
It's faster than I can swim.
Yeah, probably. Apparently Michael Phelps swims at like 6 miles an hour.
Oh, wow.
But 2 miles an hour, yeah, it's pretty slow. I mean, even 6 miles an hour is not fast enough to catch a fish like with your hand or your mouth or something.
I'm more of a leisurely swimmer.
Yeah.
Yeah.
But even with a leisurely swim ability, we can still do plenty of successful hunting in the water. So, for example, we can stand in the water and stab fish.
Mm-hmm.
That's what a lot of early people did with like spears and things like that. It's pretty analogous to what they think Spinosaurs did, except using their mouth instead of a spear. And then we can also dive into the water and collect crabs, oysters, snails, and other slow-moving animals, which maybe Spinosaurus couldn't do because of that being too buoyant, but it does have a pretty long neck, so it might be able to reach its head down, like walk around in the shore and sort of reach down and grab some food that way.
Yeah.
But yeah, I definitely don't think this is the end of the debate.
Oh, I highly, highly doubt it.
I think the only way the debate ends is if we get a lot more of the Spinosaurus skeleton so we can more precisely model its center of mass. We're still missing a lot of the back spines, most of the arms, and basically all of the ribs. So we don't have a good idea of like its exact chest size or its arms or the size of its back. And I guess there's always going to be room for interpretation too on like how much meat there was and how much air was in it.
Yes. It's interesting that we keep going back and forth between walking on 4 legs and walking on 2 legs.
Yeah. It does have pretty weak sauce looking hind legs compared to a lot of other theropods. And it has really big arms relative to a lot of other big theropods. So you can see why people think it might be quadrupedal because the hind limb to forelimb ratio are way closer on Spinosaurus than most big theropods.
I don't think I've heard the word weak sauce in a while.
Yeah. It's the right way to describe their hind limbs, I think. But it doesn't mean that they weren't bipedal. It also doesn't seem like it really matters that much in terms of swimming because you can stand on 4 legs in the shallows or swim with 4 limbs or 2 limbs.
Humans can swim and we walk on 2 legs, and dogs can swim and they walk on 4 legs.
Good point.
But what does it mean? Are we all semi-aquatic? Depends on your definition, maybe.
Yeah, I don't think humans or dogs are semi-aquatic. There are probably some breeds of dogs that are functionally semi-aquatic, like the ones that are bred for like retrieving birds from the water and things like that, but not humans. Maybe some groups of humans, though, spend a lot of time in water, I suppose.
Yeah, some people can dive really deep.
That's true. But I'm sure it won't be too long until we hear another paper about Spinosaurus. We never go more than about a year.
So there was a news item about maybe one of the few dinosaurs that could eclipse Spinosaurus, T-Rex.
Eclipse it?
In terms of how often is it talked about?
Oh, yeah. Yeah, we definitely talk about T-Rex the most.
Yeah, and it's something that didn't happen last month, is that a T-Rex skeleton did not go to auction. And this T-Rex skeleton is nicknamed Shen. It was supposed to go on sale at the end of November, and it was expected to sell for 15 to 25 million US dollars, but the auction was canceled, and it may have been because parts of it looked a lot like a replica of Stan, the T-Rex.
Oh, interesting.
Yeah. The skeleton Shen weighs about 3,100 pounds or 1,400 kilograms, and it sounded like about 79 or 80 of the bones were original. There was no official explanation for why the auction was canceled, but Pete Larson expressed some concerns that parts of Shen looked like Stan. So that might be the reason.
So he's basically saying that, or hinting at, the filled in missing pieces were his intellectual property.
Yes, because the skull looked similar to Stan's with holes in the lower left jaw. And it's possible that the owner of Shen bought a Stan cast to fill in the missing bones because 79 bones is not a full skeleton.
Yeah, it's something like 300.
Yeah.
So that's a lot of bones to fill in.
And the owner, who's anonymous, now has decided to loan Shen to a museum for public display instead. So interesting turn of events.
Yeah, if it stays in a public museum, that would be a really nice twist.
Yeah.
So then everybody can see it. Yes.
And speaking of dinosaurs in museums, the Natural History Museum in London's getting a Patagotitan.
Nice. That's the one we saw at the American Museum of Natural History too, right?
Yeah, it's 121, 122 feet long. It's going on display next year, starting March 31st, as part of the exhibit Titanosaur: Life is the Biggest Dinosaur. And it's 4 times heavier than Dippy.
Whoa.
And 39 feet or 12 meters longer than Hope the blue whale.
Wow, 4 times heavier than Dippy.
Yeah.
That's crazy. I guess Dippy, a lot of the length is in the tail, and it's a pretty thin tail.
Mm-hmm.
It's not so bulky, whereas Patagotitan was a pretty bulky animal.
Yeah. So this cast is on loan from Argentina. When you've got something so big, it's always interesting to see how it fits in the space. Like in the American Museum of Natural History, they had to redo a whole area to fit their Patagotitan.
Yeah. Yeah, they were kind of out of rooms and they just like squirreled it into a room that was like a memorial hall.
Well, the head and then part of the neck was sticking out of the room.
Yeah. Yeah, it actually kind of made it more fun that it didn't really fit in the room.
Yeah. I think it gives you a better sense. I mean, you get a good sense when you're standing next to this giant dinosaur, but when you can look at it from far away and see, it doesn't even fit in this giant room.
Yeah, it'll be interesting to see which room they stick it in London.
Yeah, if anyone visits and sees, let us know. All right, as promised, we've got, I think these are the last of the SVP dinosaur posters.
Yeah, they need to be.
They need to be.
We've been talking about SVP for too many weeks. We'll put the rest of it in bonus content.
Yes, we will get around to that very soon. So these were all posters that we were able to access online, and I'll start with the poster by Aaron Dyer and others about Gravitholus albertae, which is a dome-headed pachycephalosaur, and they examined Gravitholus to see if it was a valid taxon, a valid dinosaur. Now, in the past, Gravitholus has been referred to Stegosaurus and also as an indeterminate pachycephalosaurid. What they did is they CT scanned the skeleton and they found that Gravitholus, as well as Hansusia sternbergi, are synonyms of Stegosaurus validum.
It's right in the name. Stegosaurus validum. That's the valid one. The other ones don't have validum in the name.
I had a similar thought when I was reading this. They also proposed sexual dimorphism for Stegosaurus because they found thicker frontonasal bosses that aren't seen in the juvenile and subadult specimens, which I thought was interesting. Anytime we see something about sexual dimorphism, it's kind of like, that seems really hard to know for sure.
Yeah, it is.
They did find pathologies that appear to have come from headbutting or some kind of intraspecies combat, and those pathologies were only seen in domes with the taller frontonasal bosses, which may show that the specimens with the taller bosses were one sex. They didn't specify if that was male or female, the ones that were combating.
Presumably males, but could be females.
Yeah.
Stranger things have happened. That's actually really close to my fun fact.
Oh, well then. We'll have to wait and see about that because I've got some more news items from SVP. The next one is about the long-promised Big Al poster.
Oh, yeah, good.
This is by John Scannell and others. And they did histology on Big Al, which that's the Allosaurus that was found in the Morrison Formation of Wyoming in 1991. It's a nearly complete, partially articulated skeleton, and Big Al, of course, is known for all its pathologies. Poor Al. Big Al is also very large, at about 23 feet or 7 meters long. These pathologies could be from trauma and infection. They found Big Al to be at least 16 years old, and Big Al grew a little bit less between the ages of 14 and 16. which it's unclear if that was typical for an Allosaurus gymnadzini or if there was stunting due to illness or injury.
Yeah, I think we only have that one Allosaurus gymnadzini because that's the new species. So we wouldn't know much about it if it's the only one.
I think there are multiple specimens of Allosaurus gymnadzini. There's the holotype, and then Big Al is a referred specimen.
Oh, really? Okay. You got to cut open that holotype and see how it looks then.
So they suggested that Big Al is a female based on having tissue that looks like medullary bone, but the medullary bone wasn't fully resorbed from a previous egg-laying cycle, so when Big Al died, Big Al was not pregnant. And it's possible that the medullary bone-like microstructure may have developed in response to the injuries, but there needs to be more studies and analysis.
I see. Was it medullary bone or was it just from an injury?
We have talked about how sometimes medullary bone isn't what it appears to be. But if it is, that's really interesting. Another cool item was that David Schwimmer had a poster about a hadrosaur fossil found in western Georgia in the US. This was an isolated juvenile hind limb element. It was found by Walker Wilson in the Ripley Formation. It's poorly preserved, but they think it's probably a left femur. They can't tell what type of hadrosaur it is, but it was found, quote, in situ within 4 meters of a distinctive formation boundary between the Upper Ripley and Basal Providence formations, end quote. So it comes from the lower middle Maastrichtian in the late Cretaceous. And it's cool because it's the first reported or known Maastrichtian dinosaur fossil from Georgia.
Yeah, that's really late.
Yeah. Also, I feel like we don't hear too much about fossils from Georgia, the US.
No, definitely not. There's way more in like Montana, the Dakotas, all that. At least when you're talking about dinosaurs. If you want some marine stuff.
True. Good
Georgia's
point.
got plenty.
Good point. I was dinosaur focused there.
Yeah.
The specimen was recently donated by Wilson to the Tellus North Georgia Science Museum. So that's cool. Can be studied. Another interesting poster was by Tamanori Tanaka and others, and it's about a Hesper ornithiform from the Mesa Verde Formation of Wyoming. And Hesper ornithiforms, they were diving seabirds with teeth, basically. They lived in the late Cretaceous. Now, the specimen that they studied was collected by Marsh back in 1879, and originally it was thought to be a young Baptornis advenus. It includes parts of the leg bones, and they found it was either a juvenile or subadult, and through phylogenetic analysis found that it was different from other Hesper ornithiforms. They estimated it to weigh about 4.7 kilograms, or about 10 pounds.
Oh, it's tiny.
Yeah, that's much smaller than other Hesper ornithiforms. That's about 8% the weight of Hesperornis regalis.
Yeah, I always think of Hesperornis regalis like an emperor penguin.
Yeah.
But with like crazier feet and teeth.
Yeah, that's a good comparison. So this is the smallest known one from the Niobrara Formation, and it helps show that there was a lot of niche partitioning within this group.
Yeah.
All right, our last bit of SVP news, other than in our bonus content, of course, is by Koch and others. And this one, it was just cool. It was about birds, but birds are dinosaurs, so I'm including it. They analyzed the hearts of different birds to see how it affected how they flew.
Oh, wow.
Yeah. And they studied different kinds of birds. They called sedentary birds, the non-flying ones, such as rheas and ostriches.
Thinking about an ostrich as sedentary is hilarious when they're like one of the fastest running animals on Earth.
That's partly why I like this poster so much, was because of these bird groupings.
Yeah.
There's the imperfect flyers, so short duration flyers like chickens.
Okay. Yeah, the ones that like bound, I think is sort of what they call it.
Yeah. It's kind of funny to think of them as imperfect flyers.
It's a good description. Yeah, they're not very graceful.
Yeah. And then you've got the sophisticated flyers, which are the long duration flyers like hummingbirds and woodpeckers. Hummingbirds are definitely better flyers than chickens.
Oh, yeah. No comparison.
They found that bird hearts were adequately evolved to maintain the, quote, high level of cardiac output during powered flights in both imperfect and sophisticated flyers, end quote, which makes sense because they're all, even though they're imperfect flyers, they're able to fly.
Yeah, that is interesting, though, because you could imagine the imperfect flyers just doing it anaerobically, and then they
Mm.
wouldn't need all that impressive of a heart.
They also found that, quote, heart size relative to body size correlates to improved flight capabilities by increasing the aerobic capabilities of birds across all flight styles.
Okay. So bigger hearts are better if you're trying to fly.
Yeah,
Makes sense.
it does.
You never really know, though, because it's always possible that it shrunk so that they would be lighter weight, because hearts are not lightweight.
That's true. They're quite dense.
Yeah. Very cool. I wonder if that can be applied to dinosaurs in any way.
It seems really difficult. Like, it's one of those things you can compare the living birds to the dinosaurs and draw some ideas from that, but without having a heart of a dinosaur,
Yeah.
how would we know?
Yeah, very true. They don't really fossilize, unfortunately. And in just a moment, we'll get on to our interview all about PalaeoPoems. But first, we're going to pause for a quick sponsor break. And now on to our interview, where we're going to talk all about paleontology-inspired poems. But a quick reminder, if you're a patron, you might want to listen to the extended version of this interview in your premium content feed. We are joined this week by Brigid Christensen and Mike Thompson. Brigid recently received her master's in 2020 and is the founder of PalaeoPoems, and she does the biographical research for PalaeoPoems. And Mike is working on a PhD in paleontology and sedimentology at the University of Manitoba and writes the science background behind every PalaeoPoem. And the PalaeoPoem project is obviously something we find amazing, which is why we're talking to them today. Thank you both for joining us.
Yeah, thanks for having us on.
Yeah, I'm so glad that we saw your poster at SVP. It's such a cool project.
Yeah, we have it hanging up in the basement right now because it's so beautiful, thanks to our graphic designer, Katrin Emery.
Awesome.
That's amazing. What inspired PalaeoPoems?
Yeah, so I started the project. I think I started looking in around 2017. I was doing some work for the Canadian Museum of Nature. I was looking at historic dinosaur discoveries. And while I was doing it, I had to look into the memoirs of kind of early Geological Survey of Canada geologists. And in those memoirs, I kept finding like really bad fossil poetry. And it was really exciting because I just didn't expect to find something so silly. And at a certain point, I started looking for like historic paleontology poetry. And I found a lot. And I really wanted to share it with people. So we came up with the blog. It started in earnest in 2018, launched in 2019.
Oh, wow.
And basically we compile these kind of historic and modern poems about paleontology by either scientists or science enthusiasts. So they all have like a little bit of scientific background. And yeah, it's very fun.
So what was the first PalaeoPoem that you found?
The first one I found was by Thomas Chesmer Weston. He was a geologist in Canada in the 1800s. He found a few things out in Alberta and Saskatchewan. So he was a part of my paper that came out, I believe, in 2020 about Canada's first dinosaurs, quote unquote. And so Thomas Weston only has one poem in his entire memoir by himself. He has another one by one of the guides who was with him in Saskatchewan. And his was just 2 lines. It was monsters of the prime who tear each other in their slime. And it was really amazing because I did not expect to find anything like that. I had no idea why he wrote this. And I wanted to show everyone because it was just there on the page with no other context. We found out like a few years later that it's either like an adaptation or a misquote of a Tennyson poem. But it was just so incredible and it inspired the entire project. So we kept it on our website and we just made that note about it.
Yeah, and I'm looking at your website now and it's really easy to go and find these poems and you can read them. And I know there's also audio versions, right, of the poems?
Yeah, so the website was recently overhauled by Christina Muxlow. She's a website designer and our friend. And then the audio recordings originally were kind of done by me, but eventually we had someone reach out to us, Alana Grace Self, and she asked if we took volunteers, which was very surprising and great because I was like, well, there's two of us. So sure. And so Grace Self is a fossil preparator, actually, but she's also doing a lot of voice acting. And so she reached out to us and she has this great audio setup and she really wanted to kind of flex her voice acting muscles and do some volunteering for us. And so we got her on board too.
Fun. And then every poem, I mean, you can read the poem, but there's also a lot of science behind it and also a biography of the person who wrote it. So a lot of extra information, which is really cool.
Yeah, we kind of figured at some point that because the poems are not particularly straightforward when you read them sometimes, some of them just contain a ton of jargon and stuff like that someone in the field might understand. But when you ask somebody to tell you, well, what do they mean by myacid or like any other kind of strange paleontological term like that, somebody might not know what that is. So we decided, well, we should probably just do some write-ups on just what these people are actually talking about so that you can read the poem and not be completely lost, basically. And then, so that's where kind of my job at PalaeoPoems started, was just, I decided it would be pretty fun to just write about some of them because the topics they talked about were pretty interesting, and it was interesting to just see the things that people were thinking about at the time and that kind of science, and just kind of going back in time and looking at it was interesting too, and just seeing oh, this is what they thought, and then writing a bit about that, and that kind of goes into some of the biographical stuff that Brigid works on most of the time too.
Yeah.
Yeah, I wanted to provide a biography of all the people who wrote the different poems because a lot of them are people who are lesser known in the field. Like Thomas Chesmer Weston, for example, is a very niche person to know about. If you're in historic Canadian geology, you might have an idea about who he is. I spent a lot of time with his memoir, but I don't think anyone else has.
Yeah, I don't think we've heard of him before.
Now we know.
No, not many people have. But we also get other people like Nancy P. Morris, who was actually she was an administrative assistant at the Royal Geological Society in England. And so she was someone, this is in the 1950s, she was there during the Second World War as well. And she was someone who, interacted with science every day, but didn't necessarily have the opportunity to publish or have her name known. So she submitted her poems to the Society of Vertebrate Paleontology news bulletins that circulated. And that's where we found a couple of poems by her. So it was a really cool way to highlight kind of people who were who knew about science and cared about science and had these really creative ideas that they wanted to put into poetry, but who are really kind of unknown among scientists today.
Yeah.
What do you do when it's an anonymous poem?
We've done a couple of anonymous poems. Actually, I think there was only one so far that we've posted that we really had no idea.
Okay, I might be looking at that one. The Giant Birds of Old.
Oh, so Giant Birds of Old is interesting because I found a paper that claims to have a good guess at who it might be. So in that case, we mention that it's anonymous, but we do provide a biography of the person, James Dwight Dana, who is thought to have written the poem. Oh, and the other anonymous poem I was thinking about isn't anonymous.
Oh, no?
No, I was thinking about the Charlotte Whale poem, Observation to a Whale. We have her name, Miss Julia Pepper, but we have nothing else on her. I was really unable to find anything. I checked marriage records around the area.
Oh, wow.
Basically, she wrote this poem about this whale that was kind of a tourist attraction for people who liked to take the train. And I wrote a little briefing about how I tried to find who she was and who she might have been and what kind of life she might have had, but that's about all I could do for her.
That's not a super common name. It seems like you could maybe find something. Although, when was that poem from?
1868.
Oh, yeah. Yeah, the records get a little dicey when you try to go back over 150 years.
So my great-grandmother's line is actually the Peppers as well, but they're from... I think there were peppers all over North America. I don't think that it was, I think it was more common back then.
Oh.
It'd be fun if you were related.
Yeah.
It would be fun.
It would be fun. Yeah.
That's cool. So how did you find, I mean, I think the obvious question is how you find all these poems. It sounds like the first one you sort of stumbled onto, but then I don't think we really see paleo, like when we're reading.
Feels like you have to know where to look.
Yeah, so one of my favorite things to do to find poems, actually, so during my master's degree, which was on fossil carnivorans, I went to a bunch of different museums in the United States and in Canada to look at fossils. And when I had looked at all the fossils and I had some spare time, I would ask where the library was. Most natural history museums have some kind of like small historic library on their shelves that all the people at the collections know about. So at the Museum of Nature, it's the Sternberg Library. It was donated by Charles Sternberg. But there was one at Yale. There was one at the museum in New York. And so when I had some time, I just went and, efficiency is key. So I just was drawn to the ones that had colorful bindings or illustrations on them because they're kind of the more whimsical ones. And then I just started flipping through books because poems really jump out to you off a page since they have such a strange like structure. And I found a lot that way.
Yeah. Sometimes it's not so structured too. Like I found a couple once when I went to the museum in Joggins, Nova Scotia. I was just there doing some field work in 2018 or something. And I just sat down in a chair to wait for my colleagues to stop talking to somebody. And there was a book on the table beside me and I just started flipping through it and there were poems in it. And the book was from, I don't know, early 1900s or something.
Wow.
And I don't think we've posted those ones yet, but like, it's just like, oh, there we are. And I like text Brigid, I'm like, I found poems.
A lot. We do find some on Twitter too. So we find historic ones that people are excited to tag us in.
Yeah.
And then it's also how we've made a few connections with some of the modern poets like Susanna Leiden and Robin Lamble and Christina Olson as well. Although J. Artemis Hull, I found them from my about twice a year. I'll just start Googling PalaeoPoems to see if there's anything new. And I found that they were running PalaeoPoem workshops and I was like, excuse me.
Yeah. And then poems will stumble onto us too, because now that the website exists and that we, have social media accounts, people will learn that we exist and they'll approach us and be like, look at this, I've got poems. You want to put them on your website? And then we'll be like, okay, yeah, sure. Why not? These look fine. Like they'll find them historically or they'll be by themselves too. Like they wrote the poems. So, we get a wide variety of stuff from people who reach out to us as well.
Yeah.
One of the best sources for poems has been visiting the Yale Peabody Museum, where they let me flip through old Society of Vertebrate Paleontology circulars.
Yeah.
So about once a year, they would send out these they're almost like zines, but they're pamphlets that have the latest news on all paleontology or people affiliated with the society. But they would also be full of cartoons and poems and like cute little stuff like that. And then as well, the collections manager there, Dan Brinkman, goes through historic documents all the time and sends me any poems he finds. And it's amazing.
That is great.
That is great.
Somehow I was imagining that the project would be like, I found this one poem one time and then asked everybody else where they found their poem, like crowdsourcing immediately. It's amazing that you found so many on your own.
Mm-hmm.
It's one of the perks of going to places to do research for paleontology, to just get access to all these different things. And then, having a social media presence, you have like a global network of stuff that you can find even without trying sometimes. So
yeah. I'm clearly looking in the wrong places because people don't usually put a poem in like their peer-reviewed journal articles. They should. It would really, everyone has a paleo art. There's other types of art, they could put in some poems. I think that would maybe help sell some of these papers.
Sometimes they do, actually. We have one from, it's one about foraminifera, and it's a cute poem about the grammar that should be used when referring to them.
Oh, nice. So do you know about how many poems you have now?
I think it's like 26.
Yeah, I think it's 26 because I remember at SVP counting how many poems people had written for us on the board was 26 at one point. And then I counted, I'm like, oh, we have 26 on the poster as well. What a coincidence. So
we've published 26. We publish roughly once a month with hiatuses from time to time. And then we have I have like a Google Drive full of them. And when people express interest in doing the guest art for each poem, I send them the Google Drive of unpublished poems. They pick a poem. And then I say, okay, send me art when you're ready. Since it's a volunteer gig, I don't give them a deadline. And then eventually I get some super cool art. And then we do the blog post based on whichever poem we have the art for.
Gotcha. So you have, it sounds like probably a very large selection of unpublished works ready to go.
Yeah. There's at least, there might be about 20 in there, but, I'm finding more all the time.
Yeah.
Yeah, I think we just found one like the other day, didn't we?
Yeah.
Do you collect anytime you see a poem and you kind of throw it on the back burner? Like, yeah, we'll get to it later.
Yeah, basically we have like a little bank of poems, and they're ones that we like screen to see like if they're written by scientists or science interested people. Because there are quite a few ones about dinosaurs by actual poets and authors and stuff that'll appear. But our goal is to present poems that were written by people who actually really, really care about the science behind it.
Mm-hmm.
And in that way, they're all kind of like a form of science communication. And then we just let artists pick which poem they want to do next.
Yeah.
Sometimes if we find one that we really like, we sort of fast track it. Like most of the artists that we've had are friends of ours. And so I can be like, do you want to do this one? If it's one that I'm really excited about that we found kind of recently. But otherwise, we just kind of let people pick.
Cool. Do you have any favorite poems?
Yeah, I think my favorite poem is always going to be the Tilly Bat. It's just such a good example of what we want to do with PalaeoPoems. So it's got like this kind of lighthearted attitude about an argument between two scientists and a moderator scientist. It's about how Tilly Ettinger thought that the brain case that they found is a Paleocene brain case. So it was over 50 million years old, and she thought it was a bat, judging by the lumps and bumps on it. She thought, oh, this thing was nocturnal, this thing flew. And Glenn Jepson looked at it and he thought, no, it was like myacid or, a cat, sort of.
Mm-hmm.
Myacids aren't cats, they're like cats. And then, they had this argument and they brought in another scientist, Brian Patterson, to moderate the argument. And it was never resolved. And I actually got to see the specimen when I visited Yale for my thesis, which was really exciting because I was like, well, I'm already in the mammal section. I might as well check this drawer. And it was right there. And it was like seeing a celebrity. And then, so there was all this science to dissect because, it's one of the least accessible poems, I would say, for someone who isn't in paleoneurology specifically. Like even I have a very flimsy grasp on brain anatomy, let alone fossil brain anatomy. So we got to do a lot for the science writing. We got this absolutely fabulous art by Greer Stuthers. This was, I think, maybe the second poem that we featured. And Greer was really excited about the project. She's a friend of ours. And she did this art where she did like a very anatomical drawing of the specimen. And then on either side, you can see how it could be a bat or it could be a myacid. It could go either way.
Yeah, I'm looking at it now and it really captures that debate.
Mm-hmm. No, it's absolutely stunning. I love that art so much. And then I also got to write like pretty meaty biographies on Glenn Jepson and Tilly Ettinger because they're both pretty interesting people. No offense to Glenn Jepson, who spent his entire life at Princeton, but Tilly Ettinger was a little more interesting. She was a scientist refugee of the Holocaust, and she basically moved to the States to avoid the Holocaust. And, unfortunately, she lost her family. And the way that she was allowed to live in the United States was the condition that she finished her manuscript. So this manuscript like plagued her for the rest of her life. Like she ended up almost finishing it, but not quite. And she wanted to work on other stuff, but this was truly a condition for her to exist as like a human being and be alive.
Oof, that's a lot of pressure.
It was a lot of pressure. And Like, I think it probably got to her. Like, it took her so long to finish. And, it's taking me a long time to finish my master's. And I can't just imagine having that hanging over your head with as well the condition, like, this is the only reason you are alive right now.
Mm-hmm.
So it was really fascinating to learn a lot about her. But then also to see, like, this side of her where she also had, like, lighthearted debates with her friends at work. Like, it's just so cool.
Yeah.
Do you have an opinion, or is there a reason why you named it Tilly Bat and not Tilly Cat? Or is that the title of the poem?
That's the title of the poem, given by Glenn Jepson.
Gotcha. And then was it named after her then? Is that why it's also Tilly?
Yes, that was her name. So they called it the Tilly Bat because they said basically, like, no one knows what this thing is. It's not a myacid. It's not a bat. It's this new thing. It's a Tilly Bat. It was like a joke.
That's awesome. So was the poem way after the argument was going on, or was it sort of contemporary with the science?
Yeah, no, it happened sort of at the height of her career. Like, I think just a little bit before she became the first woman president of the Society of Vertebrate Paleontology.
That's super cool.
Mike, do you have any favorites?
And you have a favorite poem too, right?
Yeah, actually, it's the one that we are about to publish. It's called The Nautilus and the Ammonite, so it's not on the site yet. But I had not read it until, I don't know, last week or something. But then I read it, and it's just, it's really beautiful. Like, personally, I just think the poem reads super well, super evocative imagery and language and stuff like that. It basically talks about how, like, nautilus or nautiloids and ammonoids kind of show up at the same time-ish, 100 million years difference, but show up around the same time in prehistory. And then, they look pretty similar. They live a similar life, and they just go out and float around the ocean for hundreds of millions of years in friendly competition, basically, the poem says. And it just talks about their journey through time and how they see these monsters of vast size that are in these, like, ages in the past and stuff like that, and how those things come and go, and the Nautilus and Ammonite just kind of sail on and keep going. But then, in the Cretaceous, Ammonites disappear, and the Nautilus now just roams around the oceans looking for its lost friend that we'll hopefully see someday. And then, and it makes some allusion to the, like, human condition of, like, these are things that happen in the lives of people too. So sometimes you feel like the Nautilus out on the stormy sea, waiting to see its long lost Ammonite friend again. Someday they'll see each other again, the end of their journey, but who knows when that'll be, that kind of thing. So it's just this, like, very touching and, like, evocative poem that I just think is really fun to read. Nothing, like, particularly, like, scientifically unique about it or anything like that. I just think it's a nice poem.
Yeah. When was that one written?
1838.
Wow. So that's on the older end of the poems you have.
Yeah.
But the emotions are very relevant today, or, like, anytime, really.
Yeah, I find it's written in a way that's pretty easy to read compared to a lot of more antiquated poems too. The language is relatively modern and flows really well when you're used to kind of how people write today, basically.
It's really exciting when we get a poem that's actually written well.
Yeah.
No offense to the Victorian scientists.
Yeah. No, some of them are kind of stinkers.
All the modern ones are fabulous.
Yeah. Definitely. All the modern poems are really good. But then, some of the past ones, people didn't have the talent for it that they might have thought they did, I guess.
But it's okay. It's all about the effort.
Yeah. I mean, that's fine. Everybody's got to start somewhere. You never know where some of those people went. And then, poems are good sometimes and they're not as good other times. But it's just, like, worth trying if you really want to, basically. Just like any art form. So
Yeah. I don't know if we've specifically asked, but there must be some good dinosaur poems in the mix.
There's actually not that many about dinosaurs specifically. It's very funny. If you look at the timeline, the first dinosaur poem isn't for... Oh, man. They appear in sort of ecosystem perspective ones, but the very earliest ones, they thought the dinosaurs were birds.
Oh, yeah.
So they're about, like, trackways.
Was that the oldest poem you had on your poster? A dinosaur trackway that was about birds?
No, the oldest one is about a Pleistocene hyena den in the UK.
That's a deep cut.
We do have some good dinosaur poems. I'm trying to remember which ones actually have made it to the website so far. We have a few like in the bank, so to speak.
Yeah, and some of it I think relates back to, if you saw the keynote talk by Riley Black at SVP, she talks about how people kind of just didn't care about dinosaurs until, the 1950s, 60s, 70s, that kind of time. Like, people just weren't as interested in dinosaurs as other things for quite a long time because they saw them as these big, like, unintelligent, brutish animals, like big lizards or whatever. And nobody was into that. People were just like, oh, big lizards, okay, whatever. But look at these elephants and these big sloths and stuff like that. Like, people were pretty into those kind of mammals and stuff, but dinosaurs just weren't in the public eye for so long that I think there aren't that many antiquated poems about dinosaurs.
Yeah.
But we don't want to disappoint you. So we do have a few dinosaur poems. I think my favorite one is The Unpetrified Forest, which is that Margaret Matthew Colbert poem. It's just about the Triassic in that area. And so she mentions like a few dinosaurs in her poem. Her poem is kind of like a laundry list of all the species that have been found at Petrified Forest. So which one of these are dinosaurs, Mike? Hesperorhynchus? No,
I think that's like a crocodile. I don't think that there are any dinosaurs in here now that you say that.
No, come on. Some of these have to be dinosaurs.
That line, a gaggle of dinosaurs leaving in haste.
Oh, yeah. It does say the word dinosaurs. I think that's it. Because Placerius, Desmatosuchus, none of these are dinosaurs.
And so that it's all describing what's going on in her mural that she painted, which there aren't very good photos of online.
Yeah, the dinosaurs featured in it would be something like Coelophysis, because it is that kind of like Triassic age. So those are the dinosaurs she's mentioning in that poem, most likely something like Coelophysis.
And then the giant birds of old and the sandstone bird are both referring to the same trackways in Connecticut in the United States. So who were those made by?
It would have been something like Dilophosaurus, so like an early larger theropod from like the Jurassic, like early Jurassic period, basically.
Yeah, I think we usually hear Dilophosaurus.
Yeah, it would be something like Dilophosaurus or a large coelophysid.
Oh, and then of course we have the joy and sorrow of the olden times, Die Last und die Leid aus alter Zeit. We have it in English as well, but the original was in German. It was translated for us by our friend Sam Haddon. And it's all about how dinosaurs brought about their own extinction through their debauchery. So that's a lesson.
Yeah, dinosaurs and other Mesozoic reptiles, basically.
This was a real scientific hypothesis?
It was, both of his poems, I think they're all about that kind of Protestant work ethic. So there's this one about how they brought about their own extinction through debauchery. And then he also wrote the Megatherium, which is about how you shouldn't be slothful.
Oh, poor sloths.
Yeah, which I guess is like a cultural reflection of how people may have thought about dinosaurs in these like early to mid 1800s. It's just like, well, this is a big, lazy, scaly thing with no brain. So why would you want to be like it? They must have just killed themselves.
There was this sort of misconception that extinction was akin to failure.
Yeah.
Oh, yeah. Yeah, that's true. And at that time too, and for a while after, it was the idea that like evolution is progressing towards the perfect form. And so like dinosaurs must have had some major flaws that they didn't make it.
Yeah, exactly.
Exactly. And we have a few poems that have kind of misconceptions like that. So we have one actually, it's called Similar Cases. And the first time you read it, it's like this cute poem about Eohippus. And then you learn a little more and you learn that it's like sort of an allegory for the manifest destiny of Eohippus. So it was written by Charlotte Perkins Gilman. Yes, the little horse. So Charlotte Perkins Gilman was an author. She's most famous for writing The Yellow Wallpaper. But she was also a white supremacist. And like she believed in manifest destiny and in reformed Darwinism. And that's reflected in her poem very subtly, which is why we always like do our background research on who we're talking about. Because, we include the poem, but we also say like, look, this is what the poem really means. This is what she really believed. This poem is not to be trusted. And like these sort of things kind of crept into the foundations of how science was done and how it continues to be done, because we're always building on what like how people used to do science.
Mhm.
And so when we build on that uncritically, then we kind of perpetuate these harmful practices. And that's how we get to kind of exclusionary practices today. The one that's less subtle that I love using as a case study is called, is it ballad or is it ode? I think it's the Ballad of the Ichthyosaurus.
The title is innocuous.
The title is innocuous. So this is by May Kendall, she was a writer in England in the early 1800s, and she was really into science. And I find her like a really interesting figure because she was like a writer and a poet, and she wrote satire, and she was really critical of people who use science to back up like sexist ideas. But in her poem, she makes it quite clear that she wasn't critical of everything. And she talks about phrenology in the same breath that she mentions geology and biology. And
she literally says Aryan brain at one point. So
the Ichthyosaurus in the poem has a large eyeball but a small brain. And that's the plot of the poem. And the Ichthyosaurus is lamenting that he'll never be known for his brain because everyone's so mesmerized by his beautiful eye, but he wishes that he had a complicated, large brain, an Aryan brain. And so to me, this is indicative of how, this woman, she was interested in science, but clearly she wasn't very critical. And honestly, she may have believed, like she might have been racist. And so when she read her magazine every day and they mentioned like updates in geology, updates in biology, updates in phrenology, she just accepted it as fact. And so that's how she ends up repeating it in her poem. And that's how this kind of became prevalent in society as well, as people were uncritical, they were biased, and they accepted it. But it's just so ironic because she was also very critical of Darwin's ideas that, human women were inferior to human men because they were evolutionarily inferior.
Yeah. It's always easier to think critically when you're the one on the losing end of the critique.
Well, exactly.
Yeah.
And so that's what, like, basically she was a white feminist, and she wasn't critical of these kind of racist ideas, and phrenology is not a real science.
No, just to be clear.
No. Just to be clear.
Yeah, but a lot of that stuff, I mean, we've talked about, the American Museum of Natural History and how it had like eugenics stuff. Like they hosted a conference on it, and their curator was
Henry
like,
Osborne,
yeah, he was like super into it and everything. So you could imagine how someone writing a poem about Ichthyosaurus and it's like reading, the pop science stuff of the day would just include it because it's hard. It's hard to think critically sometimes.
No, so I find that very fascinating.
Yeah, definitely. It sounds like that was a really good idea for a poem. I love the idea of an animal with big, beautiful eyes, but is like lamenting its other shortcomings. But it's unfortunate that it has this pseudo-scientific and pretty racist side to it.
Maybe someone could write an updated version.
Right. The children's book version.
That would be great, honestly.
Well, for our listeners then, where is the best place to find, well, obviously your website, to read these PalaeoPoems? Are there any other places to go and find out more about you and your work?
Yeah, so you can go to www.palaeopoems.com. For now, make sure you include those W's because we just updated our website and we're working on editing our redirects. The blog is our main source of outreach. So we do a new blog post about every month. And then we use social media to announce it. So we have an Instagram and a Twitter. Both are at PalaeoPoems with an A. So the British and Canadian way, which is sometimes where missing poems go when people find them and post them on Twitter. And then we do have a newsletter as well. The newsletter, again, is literally just once a month. We tell people, look, we have a new poem up. Thank you. And mostly it's my family members, but we would love to have other people on there as well. So that is on tinyletter.com/PalaeoPoems, again, with the A in front of the E in paleo.
Nice.
Great. And we'll be sure to post this in our show notes too, so people can easily access.
Awesome.
Cool.
Awesome. Well, yeah, thank you both so much for joining us. That was really interesting. I love hearing all about these different poems and the wide range of topics that they cover.
And a different way of looking at science too.
Yeah.
Yeah, thank you so
Yeah.
much for having us. We love talking about PalaeoPoems.
Yeah, thanks for having us on.
Thanks again, Brigid and Mike, for coming on the show and telling us all about these different PalaeoPoems. It was really cool hearing about just how far back in time they went.
Oh, yes, and looking at paleontology through this other art form.
And in just a moment, we'll get on to our dinosaur of the day, Eucamerotus. But first, we're going to pause for one last sponsor break.
And now onto our dinosaur of the day, Eucamerotus, which was a request from Amado Titan via our Patreon and Discord, so thanks. It was a sauropod that lived in the early Cretaceous in what is now the Isle of Wight, England, in the Wessex Formation. And it looked like other sauropods, with the long neck, the 4 columnar legs, and small head. It's been depicted as having its neck more upright, like Brachiosaurus. There's one estimate that it was about 49 feet or 15 meters long, based on the vertebrae and assuming that it is a brachiosaurid. The type species is Eucamerotus foxi, and the genus name means well-chambered. It refers to the hollows of the vertebrae.
Oh, I thought it was going to have to do with a heart after all that talk about hearts.
That'd be funny.
Although, how would we know?
We definitely would not know about this dinosaur because only a neural arch has been found.
Oh, man.
It was named by William Blowes in 1995. John Hulk did name Eucamerotus in 1870, but he didn't give it a species name. And in 1870, he wrote about the, quote, neural arch of a huge Wealden vertebra and described that arch that William Fox had found. Later, John Hulk referred Eucamerotus to be a junior synonym of Ornithopsis. And Ornithopsis was a medium-sized sauropod. The genus name means bird-likeness.
That's a fun name.
It is. In 1882, Hulk described pelvis fossils as Ornithopsis eucamerotus.
So they didn't have overlapping material. I guess you just figured it's around the same size and the same place, so must be the same.
Something like that. In 1882, Hulk wrote about the pubis and ischium of Ornithopsis eucamerotus that the late Reverend William Fox, who had found the bones, quote, permitted me to take a rough sketch of them, but for a long time he would not allow their complete extraction from the rock, nor the readjustment of the many fragments into which they were broken, end quote. And then eventually the British Museum reconstructed those fossils. In 1995, then, William Blowes said that Eucamerotus was a valid brachiosaurid.
Really?
Yes. The species name, foxi, is after William Fox, who collected most of the fossils that was later assigned by Blowes as the paratypes. So even though it was described based on a neural arch, there are a few other fossils found that have been referred to it.
That definitely helps.
Yes. It's still very fragmentary. Now, Blowes said that Owen, Seeley, Hulk, and others established several sauropods, quote, mostly based on inadequate material, end quote. For example, Ornithopsis hulki was named based on 2 dorsal centra.
Back vertebrae. All these dinosaurs, especially sauropods, just named based on a couple vertebrae. Not a big fan.
Well, not all of them, but anyway, Blowes found that only the holotype of Ornithopsis was Ornithopsis, and that other fossils that were referred to Ornithopsis were either Eucamerotus or Sauropoda incertacetus, just some kind of sauropod. In the past, Ornithopsis and Eucamerotus have also been synonymized with Palaeosaurus, but Blowes said that they should be considered separate because none of the type specimens have any overlapping fossils to compare with.
Yeah. I tend to go a little bit more in that direction.
Yes. Then Blowes referred dorsal vertebrae and other fossils, those 5 paratypes, to Eucamerotus. But actually, not everyone agrees with this because they don't have the same features as the holotype. S.V. Powell wrote about how Ornithopsis and Eucamerotus were named based on type specimens that were, quote, unquote, pretty undiagnostic. Though the neural arch of Eucamerotus does have one unique feature, which are robust parapophyses, projections of vertebrae. In 2001, Naish and Martel suggested that Eucamerotus was a dubious brachiosaurid, and Upchurch and others in 2004 considered it to be dubious. But then Campbell and others in 2017 found Eucamerotus to be valid, though I'm not sure if that paper was peer-reviewed. It was hard to check. There's another specimen known as the Barnes High sauropod that may be Eucamerotus. It's undescribed, but it was found in 1992 in the Wessex Formation, and it's about 40% complete, with similarities in the vertebrae to Eucamerotus.
That would definitely help a lot.
It would, except the ownership of the specimen is complicated and it doesn't sound like it's available to researchers.
Ah,
Yep. Maybe one day. Now, Eucamerotus lived in a semi-arid environment with lots of conifers and ferns. Other dinosaurs that lived around the same time and place included other sauropods, theropods such as compsognathids, spinosaurs, tyrannosaurs, raptors, and ornithischians such as iguanodonts and heterodonts. And other animals that lived around the same time and place included fish, turtles, plesiosaurs, pterosaurs, and mammals.
and our fun fact of the day is that ceratopsians broke and lost their horns in many different ways.
Ouch.
I told you earlier that I had something related to females damaging their heads while headbutting,
Yeah.
and I will get to that, but
Okay.
got to get through the ceratopsians first. So there was a poster at SVP by Caleb Brown. I guess we had one more to talk about.
Oh, true.
It's an analysis which included 13 pathologic horns from different ceratopsians. There were 5 triceratops horns, 3 from Centrosaurus, 2 Anchiceratops, and 1 Agujaceratops. And 9 of them are the large horns above the eyes, also known as postorbital horns, while 4 of them are from the horn in front of those horns above the nose, also known as the nasal horn.
Mm-hmm.
3 of those nasal horns are on Centrosaurus, which has a much larger nasal horn than brow horns. So it's not too surprising.
All right.
But all 13 of these horns showed evidence of healing or remodeling.
Oh, so they were alive while it was healing.
Exactly. So they weren't broken after it died and, during the fossilization process or anything.
So they felt that pain.
Yes, definitely. There were several different causes. The Agujaceratops is completely missing a horn. But that, well, actually, it's better than you were thinking.
Okay.
It appears to be a developmental malformation.
Okay.
So it probably just never had it in the first place.
So it was just made it less competitive somehow, but it didn't necessarily hurt.
Yeah, I hope so. Both Chasmosaurus horns appear to be resorbing because of their old age. Interestingly, it's asymmetric, so one horn is resorbing, but presumably the other one isn't. I don't know what that's about, but I guess as they're getting older, it kind of reminds me of like osteoporosis being more common in older humans.
Mm-hmm.
Maybe something similar is going on. They're using that calcium from their horns for something else.
Ugh. Can you imagine if like the bones in your, I don't know, fingers were reabsorbing and then some of the fingers were reabsorbing faster than others?
It'd be weird. But these are more of a display structure. They're not super functional other than like for combat.
That's true. I couldn't think of a comparable.
I think it might be like an earlobe or something.
Yeah, but that's cartilage, so.
Yeah, but it's not something you really use on your head, and it would make you look kind of asymmetric and unusual, perhaps. It also reminds me a little bit of Pachycephalosaurus and how it's been proposed that as they got older, their horns shrunk and then the dome grew. So it could have been using that for something else. So maybe it was like still growing and it just used that horn material somewhere else in the body for like, making bulky or leg bones or something like that.
A metamorphosis of some sort.
Mm-hmm. So those are the non-fighting related injuries, but the vast majority, 9 of them, appear to be broken as a result of a traumatic injury.
No.
So the tip of one Triceratops horn was most likely bitten off by a T-Rex.
Oh. Was it the only thing it could get because there's not that much nutrition?
No. And I think the T-Rex probably got the worst end of that deal because that means that there was a Triceratops horn in its mouth. And we know, I think there is actually a case of a T-Rex that has like a hole poked in it, presumably by a Triceratops. So you don't want to have a Triceratops horn in your mouth, even if you do manage to bite it off. It's going to cause a lot of damage in that battle.
Just a reminder that even though T-Rex was this apex predator, it was still hard to get food. Triceratops was a formidable prey.
Yes. There's also one Anchiceratops that has a horn that's separating, presumably from pseudoarthrosis, which was a new word to me. Usually when people talk about pseudoarthrosis, it's when you get back surgery and it doesn't like work properly and the back doesn't like fuse well afterwards. But in general, it's a disease where a broken bone doesn't fuse properly afterwards. So I'm guessing what that means is this Anchiceratops got injured, it sort of split its horn a little bit, and then it didn't heal properly afterwards, so it just stayed disconnected.
Ugh, ouch.
Yeah, that's not ideal, and it probably is pretty painful. The rest of them, though, were broken by trauma, but it's unclear with what and in what circumstances.
Mm-hmm.
Brown basically proposes that it's from competition within the species, similar to how bovids with big horns battle for mates. And as evidence, we've seen a lot of Triceratops that have like scratches on their frills and other indications that they're getting poked at by other Triceratops horns. So it definitely seems like that sort of stuff was happening a lot. And it's not out of the question that they would have broken a horn or two once in a while doing that. As evidence for the fact that it might be similar to bovid behavior, both Triceratops and Centrosaurus break about 5 to 6% of their horns. So like of all the skulls we have, about 5 to 6% of them have broken horns. And that's a pretty typical rate for what we see in bovids today. So about, 1 in 20 breaks a horn in this sort of combat. Not really that many. As a bonus fun fact, this is the one I was telling you about before, the bovid with one of the highest rates of broken horns in the dataset is the female Thompson's gazelle, aka the Tommy.
Oh, okay.
Interestingly, it is the female specifically. The males really don't break their horns all that often, but the females break them all the time. So I was very curious about this and I dug into it to find out what's going on with the Tommies.
The Tommies.
Because every other species has more broken horns on the male, at least in the data set that they included on the poster. Nearly 20% of the female Tommies have broken horns, which is a lot.
That's a large percentage.
Obviously, it's like 4 times as much as Triceratops, Centrosaurus, and a typical bovid. So it's probably not, though, because the females were especially aggressive or they were the ones doing the intraspecific combat. It's really just that the females have tiny, weak horns that break really easily compared to the males.
That's disappointing.
Yeah, it's a good example of how statistics can be really misleading if you just look at the numbers out of context, though.
Because you could assume, the females were the aggressors.
Exactly, because the whole thing is about, these animals are breaking their horns, smashing them into things or fighting or defending themselves and things like that. And then it's like, these females are breaking their horns. Why is that? And then you see pictures of them and it's these 2 little dinky horns on the top of their head and they're just like a little bit lopsided.
Right. And maybe they're just doing, minding their own business and something happened.
Exactly. Yeah. They could have just bumped into something too hard. There are some proposals that female Tommies are losing their horns slowly over the generations as like an evolutionary vestigial thing that's just like slowly going away. But I don't necessarily agree with that because apparently they often headbutt predators to protect their young, and having some small horns might be really useful in that context.
Sure.
Actually, when you look closely at what the non-broken Tommies, female Tommies horns look like, they kind of resemble a couple of shivs sticking straight up out of the head. They're like very sharp, pointy, they're small, but like you can imagine if something is running at you with that, it's sort of like, running at someone with like a small, sharp spear. Like you want to get out of the way.
Right.
Or it's going to hurt.
Sounds like it hurts both sides.
Yeah. But only 20% of them are broken in the wild, which means most of the time they don't break. And it could just be because it's a good enough threat that things are like, okay, I'm getting out of here. So, yeah. But I do wonder if any of the ceratopsians that lost horns or broke horns were defending their young. It does seem like one of the times you might stand your ground and really, fight it out.
Yeah, that's a good point. One of those things that's really hard to know.
And we don't see a whole lot of sexual dimorphism in dinosaurs, so it's possible that maybe the males were breaking their horns, fighting with each other, and the females were breaking their horns, fighting off a T-Rex that's trying to eat their babies.
Yeah, it could be.
Although, of course, we don't even know for sure that these ceratopsians defended their babies, but if they did.
It's nice to think that they might have.
There's some evidence. We see these bone beds with different age groups and things.
And that wraps up this episode of I Know Dino. Thank you for listening. If you want to get a nice piece of art to hang up in your home or maybe your office, then make sure you get on our Spinosaurus tier on Patreon soon. It's a nice, colorful pair of Microraptors. You can join at patreon.com/iknowdino. Thanks again, and until next time.